In the previous two examples, we used function notation to call on a specific function and ask someone to evaluate that function when x is equal to some specific value. We can also evaluate functions for algebraic expressions, meaning in this case, for example 8, we're given the function r of x. We want to find r of x plus 10, which means everywhere we have an x in our expression, we're going to substitute in x plus 10. So we're not just evaluating the function at a number, we're evaluating it at an expression. But the general idea stays the same. We would write -10, and as soon as we hit an x, we would plug in this expression inside parentheses, x plus 10. The same idea as if we had plugged in 0 to find r of 0 or plugged in 2 to find r of 2. We're just substituting in that algebraic expression, and now we simplify. We can start by distributing that -10 through, and then combine any like terms. Similarly, in example 9, now we're calling on this function c of x. Everywhere an x occurs, we're going to plug in x minus 4. Meaning we'll have 3 times the quantity x minus 4 squared plus 5. We're going to need to pause our work here for just a second to talk about how we evaluate this expression x minus 4 squared. This is the same thing as saying x minus 4 times x minus 4, because anything squared is that value times itself. And from here, there are two different ways to think about expanding this out. If you remember how to FOIL, first, outside, inside, last, great, do that. If not, what I'm going to tell you to do is think about taking the first value in this first expression and distribute that through the entire second expression, and then take the second value in this first expression and distribute that through this second expression. Meaning we're going to rewrite this as x, that first value, times x minus 4, that second expression, minus 4, the second value in that first expression, times that second expression. So if we distribute through, we'll get x squared minus 4x minus 4x minus 16, or x squared minus 8x minus 16. So this will end up being 3 times x squared minus 8x minus 16 plus 5. Then if we distribute that 3 through, we'll get 3x squared minus 24x plus 48 I just realized I made a mistake. Let me jump back here. When we distribute that -4 times -4, this should have been plus 16, which would make this plus 16, and that's why we should get positive 48 there, plus 5, or 3x squared minus 24x plus 53. Sorry for my mistake there, but hopefully that makes sense how we went back and caught that. And then we'll do the same thing when we look at example 10. We'll take -4 times this quantity x plus 1 squared plus 3. To determine what x plus 1 times x plus 1 is, we'll take this x times that second expression, and then the 1 times that second expression to get x squared plus x plus 1, or x squared plus 2x plus 1, which will give us negative 4 times x squared plus 2x plus 1 plus 3, and then distributing negative 4 through will give us negative 4x squared minus 8x minus 4 plus 3, or negative 4x squared minus 8x minus 1. So again, all we're doing with these problems is evaluating the function at this expression inside the parentheses. The same as if that was just a number, but rather than plugging in a number, we're plugging in an algebraic expression and then just working and simplifying from there.